So today's lesson is evaluating nth roots and using rational exponents. So for an integer n greater than 1, if b is raised to that integer and it equals a, then b is the nth root of a. So if we're thinking about that, we're only talking about some positive integers here, no negative numbers, anything like that. If a is greater than or equal to 0 and m and n are positive integers, then a raised to m over n could also be written as a radical where the bottom number of the fraction becomes the root of that radical, and the top number of that fraction, the numerator, will become the power. So the way I always remember this is that the root is on the bottom, just like if you think about roots on a tree or something like that. Roots are on the bottom, so the root is the number from the bottom, and the powers are the number on the top. So if you have the power, you're on top. You can write the power outside of the parentheses, which then would also equal the same thing as if it was written inside the parentheses like this. So n is the root and m is the power. So for example, if we were going to do a to the 1/2 power and rewrite that in our radical notation, the root, which is 2, is the number from the bottom, and the power is the number from the top of the fraction. So it would be the square root of a raised to the first power. Now typically, just as when we have a coefficient of x that's a 1, we don't write it, or if our exponent is a 1, we don't write it, it's implied that it's there. When we have a 2 as our root, square root, we do not write that. So it would just look like this, right? Same thing with that 1. If I'm putting a 1 as a power, I'm not going to write it. Another example would be, let's say, if I had a to the 1/3 power. So this could be written as the cubic root of a, again, to the first power, which of course we don't really need to write that 1, because when something is raised to the power of 1, it's just going to be that number itself, right, or that variable. So what if we had, let's say, a to the 3/4 power? Then that could be written as the 4th root of a to the 3rd power, which could also be written like this as well. So you can kind of get the idea. So then if we have a raised to, let's say, the 1/n power, then that would be the nth root. So we don't have a specific number there, just a variable. We're just going to say it's the nth root of a. Okay, so when we talk about real nth roots, there's a couple things that follow. So when you take an odd root of a number, you will get one solution. Okay, and if you think about what does it mean when we take the root of something, that kind of makes sense, because if we're saying, let's say the cubic root, but that would be an odd root, or the 5th root, that would be an odd root, you're asking yourself what number multiplied by itself that many times would equal the number inside here. So for example, if you had, let's say, the cubic root of 8, right, you're saying, well, what number multiplied by itself 3 times would equal 8? And 2 times 2 times 2 is 8, so that would equal 2. So there's just one solution. If you had the cubic root of -8, for example, that can still be actually solved using real numbers, because -2 times -2 times -2 would also equal -8. Now, when you have an even root, when you take an even root of a number, you get 2 solutions. Okay, and we talked a lot about this before with square roots in previous sections, And that's because if, for example, if I'm going to do a square root of, let's say, 4, right? Well, was that 2 times 2 that got us to that 4, or was it negative 2 times negative 2 that got us to that positive 4? Either one is feasible, so that's why we would have our answer plus or minus 2, and that's why there's 2 solutions when you're taking an even root. Same thing would apply if you had the 4th root of, let's say, 16, right? So that could have been 2 times 2 times 2 times 2 to get us that 16, or it could be negative 2 times negative 2 times negative 2 times negative 2 to get us that 16. So the answer would be positive or negative 2. So this is why when you take the odd root of a number, so cubic root, a 5th root, a 7th root, whatever, you're only going to have one solution. Even if the number inside there is a negative, you can still solve it and get a real number solution. When you take an even root of a number, where you have a 2, a 4, 6, 8, and so forth, there's always going to be a positive and negative version of that solution as far as real numbers are concerned, because we don't know which one it was. And then finally, when you take an even root of a negative number, this one was of a positive number, you have, or you get 2, and you probably guessed it, imaginary solutions. And we've talked about that in previous lessons, where when you go to do a square root of, let's say, well, we don't really need to write the 2 as we talked about before, but let's say we're going to do the square root of 9, right? Well, it's positive or negative 3, but if I go to do the square root of negative 9, you can't do that, right? Because there's no number that's a real number multiplied by itself that would equal negative 9, because in real numbers you would need a positive times negative, so that's why you would get positive or negative 3i, as we talked about in the earlier chapters. Okay, so now let's do some examples based off of what we just talked about on the last page. So we're going to just be taking, these are our root values, and these are the numbers that are going to be inside our roots, and we're just going to be putting them into that radical notation. So if we were going to rewrite this, right, it would be the cubic root of 8. And now we're just going to find these roots based on the notes that I just gave you on the last page. So this one is an odd root, right, because 3 is an odd number. So we're going to do the cubic root of 8. And as we said on the last page, when you have an odd root, you're only going to have one real solution. So what is that number that multiplies by itself 3 times to get 8? That would just be positive 2. So there's just that one solution. Now if we move on to number 2, this time we also have an odd root, it's 5. But this time we're finding what is the 5th root of negative 32. Again though, since we have an odd root, there's still going to be one real number solution. So what is that number that multiplies by itself 5 times to get negative 32? You guessed it, negative 32. Or negative 2, I'm sorry. So again, one solution there and one solution there because they were odd roots. So one real solution for each. Now for number 3, this time we're going to be doing a 4th root, which is an even number. So as we went over on the last set of notes, the even roots have 2 solutions, right? And if the number inside is a positive, then we know there's 2 real solutions. So what is that number that multiplies by itself 4 times to get positive 81? It would be 3. Now for number 4, if you're doing this one, this is a 6th root of negative 64. Again, even root, there's going to be 2 solutions, but this time we're dealing with a negative inside, so we know that there is actually going to be 2 imaginary solutions, which means there are no real solutions. So depending on what the directions are asking for, in this case they were asking us to find the real roots, so we didn't actually have to go ahead and solve it. If you were going to solve it though, it would be positive or negative 2i, and we've done imaginary numbers in a previous chapter, so that might be something that you're already familiar with. Then for number 5, we're doing the 8th root of 0. And this is our one exception because even though it's an even root here, you'd think, okay, there's going to be 2 solutions, but the square root of 0 or any root of 0 is always 0. So you just have that one answer of 0. So now let's talk about rewriting the expression using rational exponent notation. Here's our little reminder or refresher from the notes on the previous page. How we can go from the radical notation into the rational exponent notation. So again, if you remember what I said on the last page, the root is going to become the number on the bottom. So remember, roots are always on the bottom. And then the power will be the number on the top. So that's how we're going to set that up. So this is going to become 9 raised to 3 over 4. Notice my root, which was 4. This is a 4th root, 1 on the bottom. The power, which was the 3, 1 on the top, and that would be how I would rewrite this into rational exponent notation. Okay, number 2, the problem initially would not have a number in there, right? A square root, we don't typically see the little 2 in there. So a lot of times people will look at this and they'll think there's a 1 mistakenly, because a lot of times when we're missing that exponent or that coefficient to the variable, that means there's a 1 there, right? But in radical notation, when you don't see anything, that means it's actually really a 2, right? So this would be 10 raised to 7 over the 2nd power. And then finally on number 3, we have negative 21. Because it's a negative, I'm going to make sure I put that number in parentheses to indicate that that entire number, the negative included, will be raised to the power. Again, my root is a 5. That's going to go on the bottom. And my exponent is a 2, so my power will go on the top, and that will be negative 21 to the 2/5 power. So now we're going to do it in reverse, right? So rewrite the expression using radical notation. So this time, I'm going to do my notation, my radical, my 14 goes inside. Now remember, the bottom number is the root, so that 4 is my root. It's a 4th root of 14. My power is just going to be this 1, which obviously when you raise it to power of 1, it's not going to change anything, so you really don't need to write the 1. For number 2, we would have 8, and it's going to be the 5th root, and then this would be raised to 3. And then number 3, we have negative 27 inside. The root is a 3, or a cubic root, and the power would be 4. Now, one of the reasons why we might want to write it from the rational notation into the radical notation is because it's actually, believe it or not, a little bit easier to do in your head. Most people probably would not be able to say, what's 14 to the 1/4 power in their head and just be like, oh, I know what that is, right? But if it was a perfect 4th or perfect cube or perfect square, whatever the radical notation is that you're trying to solve, you might be able to work that out in your head a little bit easier if it's in this notation. So these ones would not work out to, let's see, whole numbers or anything, so we're not going to worry about them too much, but you'll see as we go through some examples on the next page. Okay, so now we're back to do a couple more examples. So if we take a look at this is just a little reminder. So we just talked about how when we have a number raised to that rational exponent notation, that we rewrite it with the root being the number from the bottom and the power being the number from the top. But we haven't done any negative rational exponents yet. So if you remember back to when we talked about exponents previously, when you have a negative exponent, in order to get rid of that negative, you would basically take that term and write it as a reciprocal. So that's why this a and this whole term rewritten will be at the bottom of that fraction with the 1 on the top. And then that way we get rid of that negative exponent as we've done previously. So taking that into consideration. So our examples here, evaluating the expression without using a calculator. So first thing I would want to do is put it in the radical notation. So my root is the number on the bottom, and since it's a square root, I don't need to write it in there. The 9 is on the inside, and then that's going to be raised to a power of 3. Now once you first rewrite it, you want to look at just the square root part in this case and solve that, right? So the square root of 9 is going to be 3, and then I would cube that, right? to get my answer, which would be 27. And we're just going to be working with the principal roots for these, right? The calculator would do the same thing as well. So if you were to type this on your calculator, you would have to, just type it in as normal. Your calculator would not give you a plus minus 3. It would just give you that principal root. Number 2. So we're going to do, again, the square root of 16. So I don't need to write my 2 in there because it's implied. And that's going to be raised to the 5th power. So the square root of 16 would be 2, right? So I'm just going to use that principal root of 2. And then I can raise that to 5. So 2 to the 5th power, or 2 times 2 times 2 times 2 times 2, would give me that 32. Now notice I'm able to get these answers without using a calculator by breaking it down like that. I wouldn't be able to do 9 to the 3 over 2 power in my head, or 16 to the 5 over 2 power in my head, but when I rewrite it and break it down this way, then I can. So now for number 3, I'm going to put this in my radical notation. So the cubic root of 64 raised to 2, but because it was a negative, this entire thing is going under the 1. Okay, so then I can still solve this part separately, just work through that denominator. So the cubic root of 64, again, just find, well, this case it would only be a positive answer because it's an odd root. So that would be negative 4. And then, oops, hold on a second. And then that's just going to be erased there. And then that is raised to 2. And negative 4 to the 2nd power is going to be 16. So 1 over 16. Okay, then number 4, I have 32. It's going to be a 5th root. That will be raised to 2, but the whole thing will be under that 1. The 5th root of 32 is 2. And 2 squared would be 4. So that gives me a 1/4 there. Okay, so now we're going to go, this one's already written. It says evaluate the expression without using calculator, so I wouldn't want to put it in rational notation here because that's actually less advantageous to me to do it in my head. So I'm just going to go ahead and work it out. The 4th root of 16 would be plus or minus 2, but we're just going to work with the principal root, which is positive 2. Positive 2 squared would be 4. Okay, then number 16, this one is an odd root, so I can get one answer there, which would be negative 2. Negative 2 to the 5th power would be negative 32. Okay, this one again is already written in the radical notation, so I don't have to worry about rewriting it or anything like that. I'm just going to do the 6th root of 64, but you see how there's a negative on the outside? This time we want the negative answer. So I know 6th root of 64 would be plus or minus 2, but because the negative's out there, that tells me that I'm wanting to give the negative answer. And then over here, we have negative 8 to the 5/3. Now, if this negative 8 were in parentheses, then inside of here would be a negative, but it's on the outside, so that would indicate that only the 8 is being raised to that power. So just keep that in mind. That can be a little tricky. And the negative is really out here. So the cubic root of 8 is actually 2. 2 to the 5th power is 32, and then we have that negative being multiplied on the end. Remember your order of operations there. Exponents come before multiplication. And then finally this one, we also have that negative again, so the whole thing is going to go underneath. The square root of 4 raised to the 1st power, so I don't have to write the 2 because the square root's implied and there's a 2, and the 1st power I don't need to write it. And square root of 4, principal root would just be 2. Okay, so now we're going to do a few problems where we're going to actually put them on the calculator, right? So the first problem we have is the 9th root of 1,124. So if you have the Texas Instruments graphing calculator, similar to this one, right? The first thing you're going to want to do is put in a 9th root. Anytime you have a root higher than a 2, square root, there's a special button for that. Anything higher than a 2, you're going to have to put that number in first. So the first thing I'm going to have to do is press the 9. Then you're going to go to the math button on your calculator, And if you go down the menu, you should see one where there's a little X in front of the root, which I believe on my calculator it is number 5 down on the menu. So I'm just gonna scroll down there to number 5 so you can see it, and then hit enter. So now I have something that looks like this, right? The 9 with the radical, and then there's my box inside that I can type into. So I'm gonna put in my 1124 like that, hit equals or enter, and then you can see my answer, and we're rounding it to the nearest hundredth, which would be 2.18 in this case. Okay. If you're doing something like number 2, where we're going to do 10 raised to the 1/4 power on my calculator, right? If you're raising the entire 10, you want to put it in parentheses. So parentheses, 10 parentheses, so it's going to look like that on your screen. Then you're going to hit your raise button right there, that little caret button above the divide sign. And then in this case, I'm going to do -1/4. Now, depending on your calculator, if you have one of the older models, you're going to have to do parentheses, -1 divided by 4, parentheses like that on your screen. If you have one of the newer calculators, you could probably just write -1/4 up there as the exponent, because it kind of bumps it up and shrinks it down so you know that it's making it an exponent. And then you hit your enter. And again, 0.562, so rounding it to the nearest hundredth is just going to be 0.56. Okay, so then number 3, if we're putting number 3 in, we have to do the 6th root, and then we're going to raise it to a power after that. So you're going to want to start out with your parentheses, your left parenthesis. Then you're going to have to put in that 6, and then go to the math button. On my calculator, it's it's menu number 5. So it'll look like that at first. Then you're going to put in the 6 from the inside. You might need to hit the right arrow to get out of there, and then close that parenthesis like so. And then you want to raise it to 2, so you can hit that little caret key right there with the 2, and then hit enter. And you get your answer there, 1.817, which would round to 1.82 if we're doing this to the nearest hundredths place. So I would encourage you now to go down and pause the video, do the next 3, and then pop it back on so you can see the answers. So for number 4, when I type this one into my calculator, right, I'm doing parenthesis, -190 parenthesis, raising it to, and I'm going to put my fraction in parentheses because it is negative. Some calculators, you may not need to do that. And for this one, I have 0.01503, so I'm just going to round it to 0.02 since I'm going to the nearest hundredth. For number 5, parenthesis, then 7, then I'm going to go to my math menu down to that x root, and then I'm going to type in -280. Make sure you arrow out of there, close your parenthesis, and then raise it to 3. And you will get -11.188, which is going to round to 0.19. And then the third one, I'm going to do my parentheses. Then on the math menu, there's actually a button for cubic roots, number 4 on my menu. You can see what it looks like right there. However, if you want to continue doing 3 and then the x root, it will work out the same either way. I'm putting in my 112, getting out of there, closing the parenthesis, and raising it to that -4. And this would be 0.0018, and so on. So if I want to do that to the nearest hundredth, it's a little bit tricky because there's 2 zeros and then a 1. So if you just want to carry that out to like maybe the 3rd number there, just since you can't really round it to the hundredth. And that's how you're doing them on the calculator. Okay, so let's use this now to solve some equations. So just as a recall, right? If we're taking the nth root of a, we have 3 different types of solution scenarios that we can come up with. If that root is odd, so if my n is odd, then there is one real root. It could be positive or it could be negative depending on what kind of number you have inside that radical. If n, however, is even, so you're taking an even root, and a is positive, then you will have 2 real roots for your answer, right? The positive and the negative version. If n is even, so you're dealing with an even root again, and a is negative, so you have a negative number inside that radical, then there are no real roots. Technically, you only have two imaginary solutions. So just like we would solve an equation, right, we always want to move towards getting that x by itself. So if we're looking at something like number 1, we want to try to get this x by itself, so we're going to move everything the other side, right? So we're going to add that 3. So we now have 2x to the 4th power equals 162. Then we're going to divide by the 2. X to the 4th power equals 81. And now, just like when you undo a square, you have to square root it. Same idea with any type of root, right? So if we have a 4th power, I'm going to 4th root both sides here. So the 4th root and the 4th on the x would cancel each other out. So basically I'm just left with an x there. And then the 4th root of 81, because it's an even root and 81 is positive, you're going to have two real roots, which are going to be positive and negative 3. Now at any point during this video, once you kind of get the hang of what we're doing, I encourage you to just pause the video, work out the problem, click it back on as I go through it so that you can kind of check your work rather than just, letting it play, but whatever you need to do. All right, so for number 2, we want to get this x by itself here. So again, we're going to move everything to the other side using inverse operations. So we're subtracting that 71. 314 minus 71, we have 243. And then of course the opposite of raising something to the 5th power would be doing the 5th root. So that's what we're going to do to kind of get that x all alone. And this time we have an odd root, so we know we're only going to have one real answer. So the 5th root of 243 is just positive 3. And now let's look at number 3. Now number 3 is a little bit different because we have those parentheses around that x. We still want to get that x by itself. We're just going to have to get those parentheses to kind of break away before we get the x by itself. But otherwise, we're still kind of attacking it with the same strategy. So first, we're going to move this 40 over by doing the inverse operation there. So now we have this x plus 12 raised to the 4. And on the other side, we're left with 21. So now, to get rid of this 4, we're just going to 4th root each side. So now I have my x plus 12 isolated, but over here I have the 4th root of 21. Now, 21 is a prime number, so we know that we can't solve that in our heads or something. We would need a calculator. So we can use the calculator, but I'm going to hold off on that for just a second. But we do know that there's going to be both a positive and a negative to whatever that number is on the calculator when we put that in. So I'm just going to have plus minus right there, and then we're going to subtract the 12. So now x is all alone, and it's going to equal negative 12 plus or minus the 4th root of 21. And if you want to work that out on your calculator, then you will get some type of a decimal answer. I'm just going to leave it like that for now, so I don't have to keep going back and forth. But remember, if you were to do this on the calculator, you would have two separate answers, right? So you'd have to do negative 12 plus the 4th root of 21, whatever that answer is. Then you would do negative 12 minus the 4th root of 21 and whatever answer that is. So actually, just to do them real quick, in case anyone is checking theirs and they want to make sure that they got it correct, negative 12 plus the, let's see here, whoops. All right, so negative 12 plus the 4th root of 21 is going to give me negative 9.859, which will round to 86. And then I would do negative 12 minus the 4th root of 21. And that's going to give me negative 14.14. Okay, so as long as you know how to do it on the calculator, that's what's important. But if you want to leave your answer in radical form, that's fine too. Okay, so number 4 here, we're adding the 20, again working towards getting that x by itself. So we have 2x cubed equals, and I believe that becomes 250. Dividing away that 2 to get the x alone. So that's 125. Cubic root. And now we just have x equals, it's an odd root, so there's just going to be one answer here, and the cubic root of 125 is just 5. Okay, number 5, moving towards getting this x by itself, so we're going to subtract the 21 first. I have 3x to the 5th equals -3. Dividing by that 3, x to the 5th equals -1. Now I'm going to do the 5th root on both sides. Now again, 5th root and the 5 cancel out. Now 5th root of a negative number, we know there's going to be no real roots, right? So you can just write no real roots if you'd like to do that. But I always like to take it a step further, especially since we've already learned about imaginary numbers. And in this case, the answer would be, actually no, it's not an imaginary number. I change back here. It is an odd root, so there's one solution, and in this case, it's just going to be -1. Sorry about that. And the last one, adding 7. X to the 4th gives me that, what is it, 10,000? 4th root. So x equals, and it's going to be the positive and the negative 10. All right, and let's do a couple more examples. Okay, so here's our last set of 6 examples for this lesson. And as a reminder, at any point, I'm just going to go through them all right in a row, but at any point I encourage you to pause the video, attempt them on your own first, and then just put the video back on so that you can check your work. So number 7, again, we're working towards getting this x to the 8th by itself. So using our inverse operations, we're going to add 70 on both sides, which gives us 60. And we're dividing that by 4. So x to the 8th is equal to 15. And then we're going to do the root to get rid of that 8. So we have x equals, and then it's just going to be positive or negative 8th root of 15. And if you prefer to pop that into your calculator and get the decimal approximation, just round to the nearest 100th place if you'd like to do that, but I'm fine with you leaving it like that. Okay, so number 8 now, we're going to add that 26 to both sides. X to the 6th equals 0. So when we go to that 6th root, to cancel out the 6th power on the x, we end up with just an answer of 0. And number 9, we're going to add 250 to get rid of that part. 6x to the 4th is now going to equal 3,750. Dividing that by 6, I believe it is 625. And then we're going to 4th root each of those, and I'm going to get x equals, now again, positive roots have 2 solutions, so it's going to be positive or negative 5. Okay, back down to number 10. Now here's when we have the x inside the parentheses. So it's important to get rid of everything outside the parentheses first, get it over to the other side, then break out of those parentheses, right? So this 5, we don't want to distribute. A lot of people make a common mistake of trying to distribute. I guess theoretically you could do it that way, but you'd have to write this binomial 3 times and do a whole bunch of distributing. So let's just get rid of this 5. Let's just get this part by itself. That's the way to go. So dividing by 5, now those parentheses are isolated, and now we can just cubic root the entire side of the equation and get rid of that 3, and as you can see, that's much, much easier than trying to multiply together 3 binomials. So now all we have to do is bring this 2 over Now notice I did not put a plus minus in front of that, and that's because it's an odd root, so there's only going to be one solution for that, so I don't have to worry about putting a plus minus. So it's just going to be a plus because 10 is a positive number, so the cubic root would have to be positive. So 2 plus the cubic root of 10, this would be the answer as a radical, but if you put that in your calculator, you could get a decimal answer for that as well. Okay, same thing for number 11 and 12. We want to isolate the parentheses. So moving over everything else. So I have 2 times x plus 1 to the 3rd power equals 36. Get rid of the 2 by dividing it on both sides. Now I can cubic root the entire 2 sides of my equation there, so that I'm just left with x plus 1. And over here, the cubic root of 18, let's see, I'm just thinking if we want to simplify this or not. I don't think it's going to simplify. Okay, so we're just going to leave it as, again, it's going to be a positive because 18 is positive, and then we have to subtract the 1. So x equals -1 plus the cubic root of 18. And finally, our last problem for today, adding that 10 which gives us 30 over here on the right. Getting rid of the entire, breaking out of those parentheses by getting rid of this exponent here just by doing the root of that same number. So now I just have 2x plus 1. I no longer need those parentheses. And over here, I'm going to have the plus minus this time because it's an even root, which indicates that there will be 2 solutions. So subtracting the 1, this gets a little bit trickier. 2x equals -1 plus minus the 4th root of 30. And then, of course, I'm dividing by 2. So x equals -1 plus minus the 4th root of 30. And that is all over 2. And again, you could work this out and get 2 different decimal answers if you'd like, but you can also leave it in the radical notation. Thanks for doing some math with me today, guys, and I hope to see you soon.